and Dr. Sanjeet Kumar Dwivedi, Fellow IET UK, IET India, and Senior Member IEEE. And he is a Senior Consultant at Siemens Gamesa, Denmark, and an Adjunct Professor at ABV IITM India. And Dr. Dwivedi has had a distinguished career, including role as technology manager at Everfuel Essers and technology leader at Danfoss Power Electronics, a gold medalist from IIT Roorkee. He holds dual master degree and PhD from IIT Delhi with 45 plus research papers and 18 plus patent and multiple books. He has made significant contribution to power electronics and renewable energy. He has served as an IEEE Associate Editor, received awards including the IET Vimal Bose Award and Danfoss Innovation Award. So please welcome Dr. Sanjeet Kumar Dwivedi. Over to you, sir.
Thank you so much, madam, for your kind words. So I share my slide now, and please let me know if you can see them. So you can see them?
Yes, sir.
Okay, and then I'm changing them so you can see they are changing also. You can see that slides are changed and content
Yes,
is
sir.
interactive. Okay, perfect. So welcome all participant, and thank you so much for finding time to get deep dive into this topic, EV and particularly autonomous EV. And as I discussed with Dr. Singh already, the core of this subject you already gone through. So I will talk in this presentation. This mobility sector, what are the challenges of this mobility sector? And one of the biggest challenge, which is the carbon emission. And why focus is required on that part, and how can we, power electronic fraternity and we electrical engineer, we can contribute here. I will also deep dive into green hydrogen role and how this green hydrogen is new normal, or it is the pathway for not only the mobility sector but including other hard to avoid sector. And then we also talk about, and we will go through, what are the challenges of integrating these green energy sources to grid, and how our battery electrical vehicle, they are having challenges and they can be solved by this green hydrogen and green fuel. So topic will be covering, it starts from, why world need to go through green hydrogen. Then later we will see that P2X and role of this green hydrogen, how it can augmented with and solving the purpose of other industries and other sectors. And later we will deep dive into grid integration part, and I will introduce grid farming part. So let's see how much we can go in first part, and then based on that, I will adjust the pace and try to cover this session in covering these topics. Please stop me and call me on WhatsApp if you see any discrepancy in the slides and my talk, or you see any break, because if I want to take any break, I will inform you. So if you see any disconnection, please call me on WhatsApp. So that's the protocol. So I will skip all those things about me, and my current affiliation is with the Siemens Gamesa, where I'm working as a senior consultant in offshore wind energy converter design. And this is my email, first name and last name with dot, and IEEE.org. That is my email, and then you can reach to me if you're having any subsequent question based on this presentation, or otherwise you are having any other question. So this is the town where I'm living. This is known as Kolding, and it is an industrial town located in middle of Denmark. So one end is Copenhagen, another end is Sunderborg, Danfoss headquarters, and third end is Aalborg, famous Aalborg University. And these three places are equally around 100 kilometer, 150 kilometer, 200 kilometer in that range. This is the glimpse of, factory. You can see that permanent magnet synchronous generator. The fabrication is going on for that. And it's a special topology where magnets are placed in outer ring. So rotor is outer structure, and inner structure is the stator. So it's solved many complications in this offshore wind, and it avoids a lot of gears and mechanical part. This is just a very popular SG14 or 14 megawatt offshore wind plant of Siemens Gamesa, which is globally accepted across the globe. So US, Australia, Korea, Europe, Norway, Denmark, and everywhere. And in India, we are also ramping up, but we are not going to that size now. But it will be reality in a couple of years, because government of India is having very aggressive planning and strategy to contribute most of the electrical energy by renewable energy sources. It's already reaches up to 60% out of 430 gigawatt, but the goal is by 2030 it will be close to 70% and 80%. As I brief you in the beginning of presentation, I will share with you challenges of mobility sector. Then why green energy focus is required. We will also look into it. So there are many drivers, but the main driver is it's coming from a global forum. It's coming from the policymaker. It is coming from the government agency and the visionary leaders. So that is something we'll see that how the development take place, and now it is the time to act on it. Then we will talk about hard to abate sector. As when we talk about passenger vehicle, then that is the only a tiny part of total hard to abate sector, and we need to include the heavy duty truck, we need to use the aviation sector, we need to use the marine sector, and then we say that it's a transportation sector or mobility sector. And then there are four more pillars of it. That is the industry sector, fertilizer sector, and then chemical sector. So all in all, this mobility sector is contributing around 1/5 of global carbon dioxide emission. Then there is a solution for avoiding this carbon dioxide emission, and that is green hydrogen. And then based on this major constituent is green hydrogen, and that is also, we say that in extended form, where we are using power to produce either green hydrogen or the derivative of it, and storing the energy in that way. So that is the P2X technology. And then this is also a major driver. And in this way, using the P2X, we can accelerate the process of decarbonizing the hard-to-abate sector. And there is a very good combination between offshore wind. It is not because I'm working in the offshore wind area. It is because I went to this area because of my interest. So first I left Danfoss and I joined Everfuel. That was the green hydrogen full value chain company, multinational company. So it was producing, storing, and distributing hydrogen. And we built the first European 20 megawatt electrolyzer plant in Fredericia. And now I'm working with the Siemens, and we are also working on very enthusiastic project, and we are developing unique offshore wind power plant. So up that's why I joined offshore wind to learn more and understand it. And because of this reason, it's augmenting or complementing the power to X very, very nicely, very swiftly. So this offshore wind power plant for P2X, that is very good model. Already Denmark is investing a lot of money on it. There is a project in Esbjerg port is running where offshore wind plant it's having accommodating a electrolyzer inside it, and then it's producing the green hydrogen. So this is something new normal for the future, where instead of rigging the oil and gas beneath sea, we are producing the green hydrogen from either wind or wasted thermal energy inside the converter, or using the excess temperature from the seawater. That's also something very interesting to know, that if the average seawater is having a temperature in the range of 30 to 40 degrees, then also there is a huge amount of thermal energy stored in it. So that may be combined and used for production of hydrogen. So we are not bounded for finding a place to dig and to produce the energy, instead of stable sea belt where this sea bottom sea rock is having sufficient strength, and this pattern of the wind as well as availability of wind that is sufficient, and that area, the whole area, can use for the production of energy. So for example, government of India is already spotted coastal area of Gujarat and Tamil Nadu. That is, this will be the source of installing the offshore wind plant and offshore wind park, and that might be also a future model for producing green hydrogen. And I will talk about it more later in my presentation. Then there will be operational and technical challenges of these wind power plant. So if we relying on energy coming from offshore wind plant, and it's coming in the form of renewable energy, then we need to integrate this energy to our existing grid, or we need to farm out of these gigawatt of wind park a local grid. And it can be also a way to strengthen our power grid. So this way, there will be many operational and technical challenges with it, and we'll see them, then how to solve them. Then this grid resilience through grid farming and grid following inverter-based resources, we will look into it also. In the end, conclusion and questions. So this is a typical, day in Delhi during this season, winter season, where you need to protect yourself from this poisonous pollution. Doesn't everybody deserve a better, air quality and clean air? It's our fundamental right, and everybody deserves it. Are we allowed to continuously pollute the environment on the cost of industrialization or cost of economical growth? Like, for example, this is a typical cement plant producing so much pollution, and it's affecting overall air quality in the area and in the state, in the country. So it's true not only for India, but it's true for the world and for development. This is often we when we talk about the mobility, we focus on passenger vehicle. We often forget about the major culprit is this sector, aviation sector. Major culprit is this marine sector, which is if we see the total pollution coming out of mobility sector, it's only 7 to 9% from the light passenger vehicle, but remaining is coming from aviation sector and marine sector. Isn't it a good idea to decarbonize these sector too? And how can we do this? Uh, we do have a solution that is called battery electrical vehicle. Okay, and then we say that no, hydrogen is not good because hydrogen cannot meet the energy efficiency of battery. What foolish we are talking about here? Battery is not a energy generator. It's only a energy carrier. And what is the form of energy? That is electrons. And when we're talking about green hydrogen, then it is also a energy carrier. But this energy carrier is quite easy to carry and store, and in the form of molecule, which is stable, which is not decaying, and which can be stored in a steel cylinder or composite material cylinder. And there are a lot of revolution coming on that area because every chemical factory, most of the fertilizer industries, and many of the places these cylinders are used. So one way we are talking about a metal or composite material storage means by a carbon intensive and hazardous, and it's quite alarming for if we talk about the health of human being, when we talk about lithium and its availability in certain percentage in environment. So if we are not doing, we are replacing whole even passenger vehicles by lithium ion battery, which is the right now bulletproof solution. This is not the way to go, and this is not the way to compare. Of course, if you can produce and store and make a network of charging and distribution of these battery through renewable energy, then of course I agree that this is the way we can compete with green hydrogen. But you see, you are using the power grid for charging the batteries, and this power grid is providing major energy from coal and gas still. And it is true for, you talk about Europe, you talk about US, you talk about India. Everywhere we are providing power through this energy, electrical energy, to the power grid through either coal or gas. And then there we are producing a lot of carbon dioxide and all the emissions coming to that end, instead of coming to your battery vehicle, your vehicle, passenger vehicle, where we are burning the fossil fuel, petrol or diesel. So you can't say that using battery electrical vehicle you can decarbonize the world. Please keep in mind, when you compare battery with the hydrogen, then you should compare apple to apple and orange to orange. And of course, I agree, if you can find a method to produce, to make a network, a strong network, that will be go to remote area of desert and remote area of Kutch and other parts of India, which is very difficult to assess. And there you can make a supply chain of these batteries. You charge batteries there in remote areas and take them and produce. And then similarly, you can complete the cycle. So discharge batteries should go to that end and then come it. But this is not viable. No business case will support it, and nobody will invest on that technology, where you rely on taking a battery to the remote end of country and then charge it and take back it. But instead, you can use renewable energy to convert it to molecules, hydrogen molecule. And hydrogen molecule, we know very well, India knows very well how to handle, compress this CNG, natural gas. India know very well how to maintain the diesel line and this petroleum lines and gas lines, and we are having expertise on it. So this green hydrogen can comes to the doorstep of industries or doorstep of big stations where it is converted back or it is provided directly to the suppliers. So, and I admit that there is a energy loss when we are producing green hydrogen from renewable energy, and when we are using green hydrogen as a fuel for electrical vehicle. In both hands, we are losing around 50% to 50 to 60%. We are only getting efficiency of 50 to 60%. So 40% we are losing. But we are making a sustainable world, and we are talking about a true business model, which can be implemented and which can be successful and which will generate lot of employment, and that employment will support energy resiliency, energy security, as well as energy infrastructure of our country and for the world also. So, and if we are not doing it, then this legacy we are going to leave for our grandkid. We have seen in just 10 days back how much fire was in US, and this was not the first time. Earlier we have seen in Uttarakhand in India, we have seen in Australia, we were seeing now this Antarctica, there is a melting of ice, and 2 days back there were how many kilometer of ice is broken, and this and then it's creating a eco disturbance in the world. And not only fire, but then the flood and then drought and these things. They're very common, and we have never listened about them earlier, and they are more and more happening. And this will be accelerated if we are not doing anything, and if we are not paying attention and not thinking of our grandkids. So, green energy focus is required. I talked to you about it. And then good thing is, in 2015, Paris Agreement. By the way, this is the agreement where Trump, he is out of this agreement. But it's not going to change anything in the world. World will continue, will follow this green energy path. Because many economy, they are based on this roadmap. So particularly European Union and India is also very keen on getting the self-sufficientness on this energy and based on this renewable energy. So in 2015, nations around the world, they agreed that rapid decarbonization is required. And then in 2018, this agreement is converted to a law by Intergovernmental Panel on Climate Change, IPCC. They produced a report which was saying that whatever we have agreed so far, world was talking before 2018 that there is if we can reduce 1.5 degrees temperature, we can lower the global average temperature by 1.5 degrees centigrade. That is enough to making safe our world. But this IPCC report was saying, what we earlier thought about 1.5 degrees centigrade, that is not enough. We need to reduce further greenhouse gases so that this average temperature goes further down. And they also realized the urgency. So what earlier thought we can take a span of 50 to 70 years to reduce this temperature, but this IPCC told this time is also less. So in by 2030 we must have some very strict measures, and by 2050 we must have to decarbonize the world. So this window of opportunity is that closing very fast for any meaningful action. And policymakers, they have already increased their effort and already working on it to eliminate these bad emissions and all economic activities. And on top of that, last year, public-private action joint statement launched at COP28. By the way, this COP28 cooperation of this project, this is focus on world environment, and this is something which is coming from this out of this Paris Agreement. And every year, world is nation around the world, they are meeting, and they will have some common consensus, and they talk about that this time. In last year, we will foster the technological and infrastructural solution necessary to supply the world with sustainable, safe, stable and affordable green energy through hydrogen. So this is something, this is not for debate, this is the world is agreed about it. So do we want to see the world like this, or we want to do the work for this? And when we're talking about this decarbonization effect, then the main culprit are hard to abate sector. And these hard to abate sector, they are producing the global greenhouse gases and making decarbonization is essential for achieving the climate target. And then we need to recognize and we need to work for reducing the pollution from these hard to abate sector. So one of the major hard to abate sector is steel and iron production. We see that industrial growth is based on that, and even the country prosperity is based on how much steel and iron is produced. So, but this is very carbon intensive process when we are producing steel and iron, and here green hydrogen can be a game changer. Not only it can, by direct reduction, it can reduce the formation of carbon dioxide, but it also make it efficient, and it can reduce the total cost of running these plants. So there are advantages not only from environment perspective but operational perspective also. And there are dedicated companies in Europe. There is a green steel companies, and there is exactly the name of company is Green Steel Company in Sweden, which is aggressively working on it in Europe. And there are other part of world also a lot of work is going on in India. Our cell is already taken some step, and we are looking forward for making green steel. Other sector is cement production. There, this is also very carbon intensive, and here also green hydrogen can play a role to provide the required heat and energy and decarbonize this sector. Then comes petrochemical sector, and here, as you know, that hydrogen is a major constituent. This is the major part of raw material in this petrochemical industry. So these industries are already using hydrogen, but this hydrogen is not solving any purpose because it is produced from fossil fuel, or it is fuel for it is produced from natural gas, so or from the coal. So if we can replace this hydrogen by green hydrogen, then we can make a game changer here also. So in even using the fossil fuel, we can reduce the carbon footprint of it. Then comes mobility sector, which is the topic of this MDP, and this is heavy transport. And heavy transport, we talk about aviation, shipping, and long haul trucking. And this heavy transport sector, which is very much relying on green fuel, because as I told in the beginning of this lecture, that battery electric vehicle, they are not a solution for this sector. Particularly aviation and shipping, no way, no business case, no business model, no planning will allow you to carry the battery for crossing the Atlantic or going from one continent to other continent for logistic purpose, same for shipping. So making options like sustainable aviation fuel and hydrogen-based fuel that is attractive, and but is still emerging. There are other alternatives are emerging here. Then we talk about oil and gas production. This is while often overlooked, the oil and gas sector itself has significant emitter due to flaring, venting, and methane leaks. So if we can get rid of this oil and gas sector, then of course this while producing the fuel for us, it is also producing a lot of pollution. And then petrochemical refineries, as I told you, the hydrogen is used for crude oil refining process. So difficulties in reducing emissions from this sector underscore the importance of continuous research, of course, and we need to work on it. And these sector, they are the major contributor for where if we can do the improvement, they can decarbonize in a faster way. However, there is a common solution to decarbonize this sector, that is the green hydrogen or hydrogen produced with green sources. And green hydrogen can be used as a feedstock for the production of chemical and e-fuel, or directly used as a fuel, like in passenger vehicle, where we are using the fuel cell and green hydrogen. So why green hydrogen? If we want to look logically on it, then we can see here, this is the perspective of energy-related carbon dioxide emission for a period of next 35 years. Here you see, these are the sector: industry, power, district heating, transport sector. And transport sector, it's taking mobility. So passenger vehicle, heavy haul trucks, aviation, marine, and then building sector, where we are talking about heating, ventilating, and air conditioning. So you see, from 10 to 15 or 20, it is going like up and up and up. Every sector is going up and up. But now we see that because their effort is going on continuously around the world, you see that how many BEV India adopted in last 3 years, and how many BEV adopted around the world in last few years. That is significantly showing the interest and then intention and effort of government and policymaker and the common citizen. Of course, this is not something which can most appropriate. This is not something which is most appropriate solution, but it is showing the intention. And similarly, in industries and other places also, people and policymakers, they are putting efforts. So this trend is not going up and up. And from we are in this area, if we see that if we keep the present emission, what is present day emission, then this line is look like this. But after this COP28 and Paris Agreement, world is ready. This is the roadmap for the world. So we will reduce these emissions in a way that by 2050, industry will reduce only this much. So around 2 or 3 gigaton per year carbon dioxide. Similarly, power sector, you see drastical reduction. So coal and gas based station, they will be the tells of yesterday's. They are not going to use much. Then district heating this is something which is essential for Europe and certain part of US and certain part of Asia also, where we are providing warming to the house through a centralized heating station, either by gas or by, particularly for district heating, we are having this warm water circulation, which is a very economical and efficient way. So this is not going to change anything, because we need to provide this warm water and we need to produce the heat for that. And then transport sector, it is having a significant opportunity, and similarly building sector. So all in all, we see that this through green hydrogen, we can change the world and we can make it more pollution free. I will take a break. You can see the next slide now. You can see the next slide now. Anybody can confirm?
Yes, sir, it's visible.
Okay, good. So now talking about these background, this is the time for using green hydrogen for these hard to abate sector and even the mobility sector. And the reason is that. And before committing it, I must say that there is no unique solution or a commercially globally commercially accepted solution is ready in the green hydrogen area. Even Europe is working and of course having the tough phase to finding the levelized cost of energy produced through green hydrogen or per kg cost of hydrogen. Same for US. And in this way, I see this is a big opportunity for India. Because we are very good in innovation. We have shown in the past. We have already shown, you see, the even space sector in atomic energy research. And we have in past, even in the health sector, we have shown in Corona time and mobile sector already. And you see our banking sector reform, UPI and other things. So India can do a lot here because there is no commercially viable or globally commercially accepted solution is ready. And saying that, this is the time where green hydrogen is reached to a maturity form, this research, development, and production that is reaches to a mature form. Of course, this cost optimization and keeping this cost below, as I said, $1 per kg, that is the big challenge. But this challenge will also possible when we go in the mass scale production of green hydrogen. So being said that, this sustainability, no doubt, green hydrogen is something where you see the full sustainability from production, storage to distribution, even in the end use. Then you see the energy efficiency. This is the part where we increase efficiency of electrolyzers and fuel cell from 30-40%. Now we reach to 60 to 70%. And so that is something commercially viable. It is not the best one, but commercially viable solution. So we can work more on these electrolyzer solution, whether it is alkaline one or it is proton exchange membrane solution or it is solid oxide fuel cell or electrolyzer. So there more and more effort are going on. Dedicated startup and companies, they are producing these electrolyzer and fuel cell. And India too have a lot of our expertise in chemical energy, in chemistry, and in renewable energy. And then I don't see any reason that we will not invent, pioneer electrolyzer technology or fuel cell technology in coming year. Then experts. So we are very fortunate. We are having a good pool of expert in this area. Because India is good in oil and gas already. Our refineries, our petroleum companies, and our chemical plants, as well as our previous experience with 200 bar compressed natural gas distribution and use, as well as our fertilizer industries handling with the ammonia storage, use, and distribution of ammonia. That is a e-fuel, for example, for green hydrogen. So we have enough manpower, expert manpower, which we can divert for the green hydrogen area. So that is also a reason why we should or must follow this green hydrogen path. Then reliability. This is something we have sufficient data from hydrogen use. We have safety standards, and we have a workforce which can analyze these data, which can work for safety and regulation and all those things. So this is also something which we say that hydrogen, of course, there is a danger associated with it. There are we need to have a protocol to use it, how to store it, how to distribute it, and what kind of production we need during production. So those are all those things. So there are manpower who can handle this and accelerate this process. So it will not take decades to reach out on consensus and roll out some standing instruction. Instead, this manpower or expertise can help us. Then electrification. This is very interesting point. Normally, I visit India every year or maybe twice, but when last time I was in December, this December, but I'm talking about the previous July. When I was in July 24 in India, and I have seen that Tata fleet of electric buses. That was eye opener for me, because in 2017 I was in this EP conference in Geneva. And there were Siemens and ABB and all the big giants, they were showing their e-buses. And there were plans to replace all the fossil fuel buses in Geneva by these e-buses. And everybody was talking, it's a future for Europe, it's a future for US. But this is the future for India. Of course, it took time because we want to reduce the cost of technology so that we can make it mass scale, we can implement it in mass scale. But it's a reality now. We are producing the cheapest and best quality e-buses in the world. We are a big exporter. However, there are challenges like drivetrain. We are still importing from Europe, and we are not having our own indigenous drivetrain. So there are some work is still to do. But this electrification, for example, e-buses, now e-rickshaw, two-wheeler, e-two-wheeler, and e-cars. So this is new normal for India, and it is also happening in the world. So these end user, they can easily be converted to hydrogen-based electrical vehicles or hydrogen-based electrification applications. And then comes sector coupling. There is a good synergy between heat and electricity when it comes to the hydrogen. Because I'm giving a practical example. If you see the solid oxide fuel cell, then it works on combined heat and electricity. So you can provide heat and you can provide electricity, and you can optimize between heat and electricity here. So and as well as when you are running electrolyzer plant or you are running fuel cell, then there is energy loss and there is a heat coming. When we say that battery electrical vehicle, we don't have sufficient heat, but if we see that when electrolyzer plant is running, then when this membrane get weak and it's increasing the drop across it, then there is a increased loss, and this loss may be 2%, 3%, or maybe 5%, depending on the capacity of electrolyzer plant and it's how old it is and when these membranes, special membranes, they are replaced. So this increased heat is waste, but it can be integrated to district heating, or this heat can be captured for some other applications. And there is a mature technology for using this heat or to connect the sectors. There is another future example I can share with for offshore wind plant when they are producing hydrogen. So offshore wind plant, normally any wind plant, its losses around 10% of its energy in generator and converter section itself. And if you say that it's a 14 megawatt wind plant, a single unit plant, I'm talking about plant, and when it's parked, then there are 100 of these plant, and it's come to the gigawatt. So if I take example of 14 megawatt, and if you lose 10% energy in generator section and generator losses and converter losses, of course, as you know that generator is PMSG, so losses may be 1 or 2% or 3%, maybe 5%, depending on the load and how much power we are in to the grid. And in converter section, so rectifier section or back-to-back GSI, so we are converting generator power to DC, AC to DC, and then DC to AC to feed into the grid. So these conversion, and even in generator, this is 10% around, and it is 1.4 megawatt, and that's a huge power. And this power can be used for heating a electrolyzer plant, which is situated close to this offshore wind plant. And even in the tower itself, we can install these electrolyzers. So that's why I'm saying this sector coupling is also accelerating this green hydrogen and its use. And then the end, this technology available. So most importantly, you have this technology, green hydrogen production, from the last century, because there are some applications which require a very a high level of purity in hydrogen, and they only rely at their location, their application, and their need, that is relying on, so that we can align only by producing them through electrolyzer. So this electrolyzer technology, Nel Hydrogen, that was a company from 100 years, Norwegian company that was producing these electrolyzers in the past. So, and it was using, of course, when you need to AC to DC conversion, then you need, it was with the mercury arc valve, then later to thyristors. But in the last few years, it's moved to the front-end active rectifier and improved topologies of AC/DC converter, where multi-pulse and multi-modular converters. We'll see in the second part of lecture how these advances they affected or contributed for the green hydrogen production. So technology is available, and now we need to mature this technology so that we can optimize the performance, we can reduce the losses in these converter, and produce cheap green hydrogen and reduce the levelized cost of energy. So this is a picture which is showing you a holistic view of green hydrogen production through how it can support the energy system, or how it will be a big backbone of energy system, and how end user are connected. So you see in the left part, it's a large scale efficient renewable energy integrations. You produce intermittent nature of energy through wind and solar, and you store them in and you use a electrolyzer plant and convert it to molecule that is stable, and that can get rid of cyclic nature of energy provided by renewable energy sources. So you're having continuous and steady supply of molecule. Then you come to the distribution part. So you can distribute by water, you can distribute by road, or you can store, or you can distribute by the pipeline. And third one is it will be act as a buffer. So think of megawatt or gigawatt of battery energy storage, which is a new normal trend in US, Europe, and even in India too. Although we don't have any gigawatt of battery energy support to the grid, but in future, if we want to make stable our grid, then we need this energy storage. And there is a one way we can store the molecules, and then we can connect a fuel cell based inverter based resources to the grid, and that way we can act. It can act to buffer to increase system resilience. So this is something we are going to see it. And when the hydrogen production is it comes to the cost of material, and there are more efficient and low cost solution is available. So it simply beat, even though efficiency is poor, but when we store these molecules, but it will surpass other, it can compete with the available solutions like battery system. And possibility of what end user can get, you can decarbonize the transport sector fully, you can decarbonize the industrial sector, and you can decarbonize the industry energy use. And this hydrogen can be a feedstock using captured carbon. So if you capture the atmospheric carbon, you can convert to the e-methanol, this hydrogen. If you capture the nitrogen from the atmosphere, you can convert to e-ammonia. So based on these green hydrogen, if you find it take as a feedstock, and it can convert to the e-ammonia or e-methanol or other type of e-fuels. Then comes to decarbonize the building heating. So this hydrogen can be directly feed in, and then it can use to decarbonize the building heating. It can mix to the existing gas, or in future hydrogen can be distributed for building heating system. So alone green hydrogen, that is something. It is a part of it. The big game or the whole solution, that is known as power to X, and this power coming from renewable energy, and X is a form where we are transforming this renewable energy. So you see that power to X transform excess renewable energy into other form, and this other form is the hydrogen. So power to hydrogen or green hydrogen production. And then we go one step further. We convert this green hydrogen to the synthetic fuel or e-fuel. So that is power to fuel. Or we convert this renewable energy power to chemicals. And then we say that power to chemicals. So, and of course, you can store this renewable energy in form of heat. So that is power to heat. So, for example, in Bornholm, in Denmark, there is island. There we are. Danish government invested a lot of money to use the earth, and then digging this and storing the molten salt water, and then storing the heat energy in this molten salt water in gigawatt hour capacity. So that is also a way, power to heat. So in this overall picture, you can see this is the renewable energy. Then comes to the power sector. So this power sector, it can be a heating sector, and this heating sector, it can do the heat storage, or it can mutually exchange the heat, and then this heating sector can be benefited by this power to X or power to heat. Similarly, power sector. So power sector, it can power to mobility. So this power to mobility part, so here it can help either charging the battery or by storing in hydrogen cylinder or in hydrogen pipeline. So it can help directly to the transport sector. And this transport sector particularly connected with the power sector. So they both interact here. And similarly, this power sector can storage the power for grid stability, and in access power can be storage, and this can feed into support the power network. And this power storage power can be in terms of individual battery or hydrogen or even the EVs. So they have the access charge batteries and carrying this, you know, energy with them and then delivering in the night time to the houses. So this is something overall picture when, and this power to X is a solution for decarbonize the world. Here,
Sorry to
one more.
interrupt you, sir.
Yes.
Sir, you asked me to remind you that we take 5 minute break. So, sir, we take 5 minute break, sir.
Yes, please take, madam. And then we come back in next 5 minutes. So that will be your time. How much? At what time we are meeting again?
Sir, 6:10.
6:10. Okay. So we are meeting
Okay,
at
sir.
6:10. Thank you so much.
Okay, sir.
Can you hear me now?
Yes, sir. Yes, sir.
Thank you so much. Thank you so much. So I would like to switch the gear and let's talk about the past, present, and future of energy generation sources. Particularly when we're talking about renewable energy based wind and solar power plant. So in the past, we were relying on large rotating mass of synchronous generator, which was having a sufficient inertia, and our learning to make a stabilized or stable power network and grid, that was basis on this inertia, because we were knowing that during the fault instant or during the brownout or in the other instances, how the
Anukriti, tell him that it is not audible.
Sir, he is audible, sir. Might be a connection problem.
can you hear me, Aditi?
नहीं
Yes,
आ
sir.
रहा है।
Yes. Sir, I can hear you, sir.
Okay, that's fine. Then if you hear me, then other who else? Dr. Singh is having problem, or who is having problem?
No, sir. HOD sir having trouble with that.
And then he need to reset his headset. Okay, thank you so much. So then we are having this nowadays. We don't have this inertia. So we are having inverter based resources, and these inverter based resources, in one sense, if you ask me as a power electronics expert, they are more efficient and they are more quicker and better solution compared to these this inertia based power generators of past. The problem is we have not developed those algorithms. We don't have sufficient data. We don't have enough experience how to use these inverter based resources so that we can have a stable and secure grid. So this is providing the modern day grid, integrating the renewable energy sources to the existing grid and make it stable. It is a matter of our dedicated efforts, consensus, and sufficient data on it. And you know that European Union already having its framework. By 2030, all the renewable energy operators they will provide they are planned in such a way that they will support the grid code and with the black start capability and with the grid farming capability. I will talk about it in the next slide. What is the grid farming? So there where IBR are becoming prevalent. We know that with the wind, solar, and batteries everywhere, we need these inverters so that we can feed in DC power to AC power, or we can convert variable frequency power to grid frequency. And then there are synchronous machines. Synchronous machine has to be derate to provide reserve and reactive power, because we know that in the past, when we were using the conventional in our conventional grid, we have to have large thermal mass and useful short circuit time rating, as well as we will have minimum stable generation, means power must be taken to obtain the services. So synchronous compensator award. So this was the status so far, but we see in the future the earlier synchronous generator-based system dominating the power system, and you see how stable it is. It is just, it is very, this inverter-based resources, they were not having any capability to disturb it or perturb it. But now it is like this. So inverter-based resources, they are the major part of the system. And then it is having capability to move the real and reactive power as well as the nature of power grid. And in this way, I will say that this it can identify and address the grid issue. It can optimize the grid performance. It can anticipate the grid fluctuation, and it can improve the grid resilience. So inverter-based resources, they are, for example, how many times outage we are getting in a national grid? Maybe 20 times in a year, or these data are from general data coming from these multinational companies who are providing this grid infrastructure. So 20 times, and for how much time? Maybe less than a minute or part of minute. So, and name any inverter-based resources, it can, through its thermal management, for those many seconds and those many times in a year, that can be overloaded. Overloaded means it can provide extra current to the grid. But this grid current must be coordinated. So system operator and then grid operator and this power operator, they must work closely with a roadmap, and then must work in a protocol, so that and they must have their own share to how much percentage of power they need to exchange through the grid in case of emergency. So this way, there are challenges for IBR-based resources to provide grid services, but the IBR-dominated power system that can increase elasticity to the grid, that can changes in IBR injected current will move the system, and this movement in system, it is itself cause IBR to move in tandem. So earlier, so far till date, all the inverter-based resources working in grid following mode, where they are having exchanging real and reactive power, but they are not having any role on the frequency change, they are not having any role on the black start capability, or they are not having any role on forming the grid. But in the future, grid forming inverter-based control, that will give that will work in a voltage control mode, not in a current control mode. So voltage control mode, and having its own voltage waveform, so we can we can perturb the frequency of the grid also in case of, and mimic the inertia nature of and power frequency curve of the grid. So not taking too much on continuing on it, I would like to give you this grid following and grid forming part, which is grid forming, that is something new, and I'm working in this project, grid farming project, first project in Europe, where we are preparing our inverter for supporting the European grid for grid farming part. So here the only requirement comes from the hardware side to provide the increased current rating. Another part comes from the system operator and from the our overall plant control. So from software perspective, how much time and when and in what rate or what rate of change of frequency we need to provide. So we see that grid following, it follow the network voltage, whereas grid farming, it farm the voltage according to voltage and frequency reference. Then power regulation, power follow prime mover here in grid following, but power follow network load. So it is more resilient and it making more interactive or making stable power network. Of course, it is, we are not having any ready-made solution, but the future is bright. Swing characteristics V delta, Q delta, or here I delta or P delta. So why grid farming is a future, not a grid following? Because wind, solar, and battery IBR arranged to follow power reference, and grid following achieve this. And grid farming require adjustable prime mover, which does not suit VRE. Batteries are different. IVR were too small to exert influence on network or debarred from exercising voltage control. So grid following was sufficient or even necessary. This is the past when IVR not having major role and they were not allowed to create influence on the network. So they were passively just following the grid. But grid following has not been required to provide services to meet grid need. Of course, fault right through, that is something. Maintaining the voltage at grid, that is something else additionally. But these two things cannot serve the purpose of grid, and it's not making a strong grid. So extending down to synchronous machine is leaving grid sort of services to meet its need. So in the past, if your major synchronous machine or your coal or gas-based plant is down, then you are having a big threat on the stability of the grid. But this grid farming inverter, this is something like a synchronous machine and meets some basic need by creating a stiff node in the grid. So it creates a voltage, its frequency changes a little is or bringing frequency to a stable point that is possible. Require a ready supply of power of energy. So here the drawback when we saying that when percentage of inverter based resources is less, then you cannot make sure that you are having sufficient availability of real power. But when we are having more than 70-80% resources based on IVR, then of course in one part of the world or one part of country there is no wind or no solar, but or in the night time when there is no solar or wind, but you do have other inverter based resources. So anyhow, you can meet in all circumstances the requirement of the grid. Then stiffness also require capacity for extra current for both reactive power and short circuit current, which is also a cost. So this we need, every IVR resources will have this over current capacity with improved thermal management, and that is also something which is we will see in the future. These are some model. We see that this current source or voltage source kind of when we're talking about grid farming, this is equivalent circuit. We can see it. I will not, and this is the performance. You see, during grid following mode, you will keep the current constant. You're not varying the current. So the current controlled current here in the grid farming mode, grid following mode. But in grid farming mode, you change the voltage. So current is not constant; it will change, and voltage is changed in order to meet the required current. These are some control principle for it. Here, grid following, it always your control is synchronized with the grid. But in grid farming, it's not needed to synchronize with the grid. It is the system operator or grid operator will have a global signals, and you can measure from the grid, and you know that where you are and where you want to go. So there is a power frequency standard curves which are fed into all these plants, IVR based plant, and they know that how to operate. So they are intelligent enough, and they are work in sync with the grid. This is some generalized control in structure of grid farming converter, and I will not take much time on it. But there are open questions that is it just software or is there is a hardware difference. There are both. We need in order to have this black start capability. Can you please mute your headset? How easy to retrofit older inverter? It is difficult. I'm saying it because in sync you need to retrofit the inverter. Then location, for example, offshore wind plant. It's a huge investment. You need to use the ship vessel. You need to take the crew to the site, and then you need to change in hardware. You need to change in hardware production. You need to update the software, and that is something not possible. So world need to act now and make their infrastructure, renewable energy based infrastructure, inverter based resources, future infrastructure must be ready to support this grid farming mode. And how much grid farming do I need in the system? So if we are having out of 100% IBR resources, if 1/4 or 1/5 they are equipped with this, then we are good, because we are talking about increased current capability during few instants in a year and a time period of few seconds. Do I need energy storage? Yes. Grid farming paired with energy storage offer full capability of grid farming responses. So this is something PQ control structure of grid following converter, and then you can compare it to grid farming converter. So here the only difference you will see that it's synchronized with the grid, this control scheme, and here this control scheme is independent of the grid. Of course, it's measuring the grid grid frequency and grid states, but it's having its own role, and in case of black start capability, it's independently can run and make the its own grid, or it can generate the start the grid with black start condition. So these are the roadmap. This is something Western Electricity Coordinating Council of US, they looked into it, and they talk about it, how the ultra high level of IBR will be enabled in and how much the energy storage, how much grid farming, and how much responsive IBR or resources, inverter based resources will be used in future. I will skip this also, and then this is the same model where you see hydro. So for renewable energy integration, you are having hydro stations, then which is equipped with inertia, then non-responsive grid following inverter-based resources, then responsive grid following, but they are having limited capability of grid fault right through and providing reactive current in case of fault, and then fully responsive grid farming mode. And then steam, and that is not responsive. So responsive is grid farming, and responsive is hydro, and responsive is grid following. In this way, they created the total load, and they have simulated, and they found it that if all IBR are grid following, then this the response they will get it. And if there is a grid farming resources, then they see this nice response. So there is a considerable improvement in the dynamics of the grid, and this way, for using grid farming mode, we are good. And this is the global landscape and timeline of grid farming specification. So IEEE already rolled out all the knowledge, and they work from last 2 decades on this. So by 2024, you see this Unify V2 version of this grid farming specification. They are available for the global user. And this is the roadmap of Europe. You see that 2030, grid farming inverter make a key collaboration for system stability. And so no IBR based resources will be allowed to be connected to the grid by 2030 in Europe. So we can conclude this green energy sources, their growth in last decade globally, and this is fuel for decarbonize the mobility sector. And that is related to our today's topic, and it is paving the way for safe future for our grandkid. And as I talk offshore wind and P2X, that is a powerful combination that can strengthen the e-mobility and hard to avoid mobility sector infrastructure by providing clean renewable energy and green fuel. So for conventional battery electrical vehicle, power grid has its own challenges with the more and more penetration of IBR. And then offshore wind power system with grid forming technology that offer a pathway for decarbonizing mobility sector and other hard to avoid sector also, and reducing dependency on fossil fuel, aligning with global climate goals. We have seen the mega trend. We talk about resilience and role of renewable energy services for decarbonized mobility sector here with the IBR water-based resources, and then we talk about advances in offshore wind, green hydrogen, power electronics, P2X, and grid stability with IBR, that is paving the way for decarbonization of the mobility sector. So I will stop here, and then, sorry, I don't have time, but at least one question I will welcome. Please ask question, because I was asked to stop everything at next 1 minute. So
Thank you, sir, for your remarkable lecture. Your ability to simplify complex idea and inspire critical thinking is truly commendable. We deeply appreciate your valuable contribution. Now I request participant, please ask question, and you can also write in chat box. Participants, if anyone have question, please write in chat box or unmute yourself and ask to sir.
I request you all, please ask question. And this might be something which, if you for the research topic or related with FDP topics or today's slides, or maybe whatever I explain you, if you are having any doubt or any part, or you see that something need to be, I should something correct, then I'm open for this. Please come up with your idea and your feedback. Okay. 1 more minute, I will wait, and then I will say thank you. There is still 1 minute. You can think of your question and ask. Yes, thanks. Who wrote this question? Just start reading it. Do you think integrating EV with renewable energy is future as well as in the union budget? Well, government is promoting EV sector. Government has allotted significant budget to develop charging infrastructure as well as. A very good point, and I will say thank you to think rationally, Mr. Singh. Where are you from? You can unmute yourself. You can introduce yourself.
Good afternoon, sir.
Yes.
Good evening, sir. Good evening.
हाँ, आप कहाँ से हैं सिंह साहब? किस इंस्टीट्यूट से हैं?
Sir, I am from IMS Engineering College, Ghaziabad.
Oh, very good, very good. So, see, Dr. Singh, my answer is we cannot rely on only on the grid infrastructure, this charging infrastructure. You think how much grid capacity we need to increase if we rely on only on the charging infrastructure, and this means charging through battery charging thing. So this is one thing. It should be continue. We need to work on it, but it's only if we provide the charging station across the country, in every village, every part, everywhere, then we can only solve this mobility sector. Only how much? 20-30% problem of the mobility sector. Remaining 70% sector is still there. And another thing is, if we put all intention on this charging infrastructure, because charging infrastructure is also not mature, it is not where it should be now. There are a lot of innovation. There are a lot of new technologies. There are a lot of new type of switching devices, like these large band gap devices, where and then their operation with proper thermal management, the things will come so that it suit from cold area 0 degree to 55 degree of desert area. So these things are there, but if we want an efficient solution, then we need to, even for the these passenger vehicles or light vehicles, we can also establish hydrogen stations. For example, my previous companies was owning hydrogen station in Europe, and there were, that Hyundai is also already having its own passenger vehicle, and Toyota is also having its own commercial model running from the hydrogen. So these hydrogen station was there in different part of Europe, in Norway, in Germany, in Denmark, in Sweden, in Netherlands. Why these are important? Because if we are not working at this point of them now, then there will be nobody will come and help us. See, this is the final solution. We are seeing that right now on our Tejas, this thruster engine of 100 kilonewton. We are not getting. Everybody is talking and everybody is saying that, oh yes, we will give you, and you are our best friend. Whether it is US, it is France, or even Russia. So we talk about countries, but talk about world, but this is the time we need to invest our own infrastructure. That's why government of India is very clever, and they are investing resources, money, and they are providing guideline also to look into this hydrogen network also. So that's my short answer to you. Any subsequent question on this topic?
No, sir. Thank you. Thanks a lot, sir.
Okay. And what are the job? This is a question coming from DG. What are the job prospects for a BTech graduate with specialization in EV? See, this is the time for any graduation in engineering. This is the time there is 100% job prospects, because if you studying your course, your students are having hands-on simulations. They are having hands-on power electronics basics. They are hands-on these artificial intelligence algorithms. Then they love their study. Then any company will prefer to take them. But of course, barely getting a degree, there is no guarantee at all for any. Even you getting degree from IIT, and if you are getting a degree without passion or without hands-on on real knowledge, nobody will hire you, because world is so competitive. And nowadays there is now we are talking, even Indian companies are talking about skills. They are talking about passion. They are talking about system level approach. They are talking about problem solvers. So forget about the old time when the electrical graduate from particular engineering college, they all inducted by electricity board or by the water commission or by the PWD. The era has gone. There are startups, there are multinational companies, there are Indian companies, there are even public sector. They are so clever. They don't nowadays. They don't have any competitive exam. They just pick the gate score and they just offer a job. So it's, if you are really love your job, your study, EV, if you are EV student and you love it, and everybody will like to hire you. Who else? How to deal with the power quality issue of hybrid grid when connected to a large number of EV near future? See, we are not. We are talking about a coordinated way to exchange the grid to vehicle and vehicle to grid power. In the future, you will see that this energy operator whose subscription you are taking to charge your electrical vehicle, he will be coordinating the balancing power with the grid. So there will be like a system operator or grid operator or transmission operator. Similarly, in the future, you will see a fleet of EV or fleet of e-buses or a regional area-wise supplier of the charging infrastructure. They will coordinate with the national grid. It is happening in Europe. It is also happening in the US. Like Tesla is having its own protocol and its own this fast charger stations at certain part of Europe and certain part of US. And they are having coordinated control and coordination with the national grid. So if we talk about the power quality issue as well as power management issue with the grid, then it will be the system operator who or the supplier who is providing you the energy for your battery vehicle. He will be responsible, and then of course indirectly you are also a part of it. So if he is making any measure, he's providing any special filters, equipment, or some kind of special kind of suggesting you to measure some parameter and provide feedback to them, then you are also part of this improvement. So in future we'll see this hybrid grid based approach, and power quality will be, the responsibility will be on end consumers, but through this system provider or energy provider to them. Any other question? Any startup option? So it is question for me or you or for participant?
This question is related to the question: what are the job prospects for BTech graduate with a specialization in EV? He asked that any startup option.
See, there are you name the topic. I can give you. I'm trained entrepreneur from MIT. So this is my favorite topic. Maybe, madam, we can arrange a lecture later on this topic for other than FDP for the same audience. But I can give you a hint here. You can work on battery technologies, even making importing batteries or getting batteries from battery manufacturer and unpacking them, or producing your own battery which is targeting or tailor-made for the EV or two-wheeler. So this is something in Delhi. There are companies, around 5 to 10 big companies. They are working only on this part. So they are not inventing anything. They just repackaging the battery. It's like a power electronics, IGBT or power module packaging kind of things. You buy chips and then you offer the power module. So same way you can start from here, and then you can think of this. As I told you in my lecture, that India don't have commercial drivetrain, indigenous drivetrain. So you can work on it. Now there are a lot of experts, and there is a lot of domain knowledge in drivetrain. Like for example, in India, when I work in IIT Delhi, I developed this direct arc control of PMSM motor. First time in India. I was the first who implemented in analog devices DSP and back-to-back connected front end with the AC/DC improved power quality high frequency converter, and load end was with this sensorless direct arc control. So I worked 25 years ago, and then I was hired by Danfoss on that technology. So I know that it's a matter of 3 generations, 2 generations. Now a lot of knowledge and maturity in this technology area is available. Somebody can start and work on this drivetrain, and they even you name the company, Tata, Ashok Leyland, Mahindra, whoever, they all importing it from UK or Germany or from Denmark. Even Danfoss is a supplier for these drivetrain to Ashok Leyland. So there are many things, and this is other area. And third area is autonomous vehicles, so which is a topic of this FDP. These algorithms and these knowledge, the database that is available in public domain, and then you can work on how to improve those algorithms, and then even there are a few startup on this area, so you can have your own startup. And then what else? In particularly in EV, so far there is one more way. If we can think of holistic and radical design, because all the car manufacturers in Europe, US, other than Tesla, even in India, they're following their own conventional car and replacing it with the EV. So if we think of it, how much strength is required, and they can do the calculations, and they can redesign, and they can come with some kind of novel materials, then there is a game changer competition for EVs also. So there are many things we can do. It's depending on the interest, expertise, and our time and resources, and how much capital money we can generate. But every NIT, every IIT and every metro and first tier 1 metro, tier 2 metro, they are having this big network, big infrastructure, big support support mechanism to provide you seed money, starting grant, and coaching, mentoring. So it's now the time for doing these startup. So if anybody is thinking of it, it's the right time for that. Any other question? Okay, but I'm thankful to you guys for responding to my call and asking these questions. And I was already taken around quarter of hour from Dr. Singh's precious time. So I say thank you so much for attending the lecture and asking the question.
Thank you once again, sir, for making this session so impactful. Thank you, sir.
Thank you, sir, Sanjeev sir, Dr. Navdeep.
Thank you so much and take care. My best wishes for your success of this FDP and the future FDPs. Okay. Bye.
Okay, sir.
Please pay attention to all the participants. The feedback form of this FDP is provided in chat box. Please fill it. Now I invite Anukriti ma'am to proceed the further program. So,
Thank you, Nikita.
over to you, ma'am. Thank you.
Thank you, Nikita. Shall we start, sir?
Yeah. We start this program.
Thank you, sir. Good evening, everyone. It's my great honor and privilege to welcome you all to the validatory session of 1 week faculty development program on challenges of autonomous and electric vehicle, organized by Electrical Engineering Department, Madan Mohan Malviya Institute of Technology, Gorakhpur. Over the past 5 days, we have had an enriching journey filled with insightful discussion, knowledge sharing, and meaningful interaction. As we approach the concluding moment of this remarkable event, it's my privilege to invite our coordinator of this FDP, Dr. Navdeep Singh sir, over the virtual dais to provide a brief address of this FDP and invite feedback from the participant. Over to you, sir.
Okay, thank you, Anukriti. First of all, good evening, all of you, respected faculty member and colleague and participant. On the behalf of the Electrical Engineering Department, I warmly welcome our program patron, the Honorable Professor J.P. Saini sir. We also welcome Professor V.K. Giri sir, HOD of the Electrical Department and Chairperson of the Faculty Development Program, and Professor A.N. Tiwari sir, Program Coordinator. It's my pleasure to welcome you to today on validatory session of 6-day Faculty Development Program sponsored by AICT and conducted by the Electrical Department of MMUT on the topic challenges of autonomous and electric vehicle. As the coordinator, it's my responsibility and honor to guide you through the enriching journey of the professional growth. The vision of the DP is to empower faculty member and research scholar to achieve their goal in the field of the electric vehicle, renewable energy integration, smart grid, power management, green hydrogen and energy management. As we come to conclusion of the 6-day faculty development program, it is a moment of gratitude and reflection. Over the past 6 days, we had the privilege of attending 13 insightful sessions, each spanning 1.5 hours, 6 p.m. to 9 p.m. This session have been filled with immense learning, thoughtful, provoking discussion, and valuable takeaway that will undoubtedly enhance our professional growth. I extend my heartfelt thanks to our Professor V.K. Giri sir, HOD of the Electrical Engineering Department and Chairperson of the Faculty Development Program, and Professor A.N. Tiwari sir, Program Coordinator, whose presence and encouraging word have truly enriched this occasion to complete this FDP program. A special appreciation to our renowned speaker and resource person who have generously shared their expertise and wisdom with us. The resource person for the FDP include experts from IITs, NITs, renowned academic and industry leaders, and faculty from both central and state university has been taken to complete this program. We are also fortunate to have a some speaker with given a fruitful experience to share with us, like Professor Ranjan Kumar Behra sir, Santosh Kumar Singh from IIT BHU, Kuwar Aditya, IIT Jodhpur, Professor Ramesh Bansal sir, University of Shahjahan, Professor Dr. Manpreet Singh Manna, Vice Chancellor of Chandigarh University, and also belonging to a professor in a Central University of Slide. Dr. Sanjeet Kumar Dwivedi sir, affiliated from Everfield, Denmark. Rahul Dubey sir, AI, Embedded AI System, San Francisco. Dr. Brij N. Singh, affiliated from the John Dheeres, and Professor Shailendra Kumar from IIT Bhilai. Professor Ashish Kumar Singh, affiliated from the NIT Allahabad. Professor R.K. Singh, affiliated from NIT Allahabad. Dr. Rakesh Maurya, affiliated from the NIT Surat. And Professor Vijay Pratap Singh, affiliated from the REC Sonbat, with us, who will be sharing valuable insight on the electric vehicle challenges and solution. I encourage you to engage actively, ask questions, share your thoughts, and learn from each other. If anyone has any query or a feedback related to a feedback, please share your thoughts for empowerment of this program. If anyone is interested, please share their thoughts, suggestion, and feedback on this program. Your feedback is most welcome, as it will be useful or its improvement. Any participant want to give any suggestion or feedback, please welcome. I also welcome to for giving any participants who wants to
Hello.
give Hello.
Hello.
Please unmute yourself.
हेलो
Hello.
हाँ नवदीप सर आवाज आ रही है
Yes, sir. Yes, sir. Please share your thoughts and
हाँ जी
suggestions, sir.
हाँ जी इट वाज अ वंडरफुल एफडीपी conducted under your leadership.
Thank you,
So
sir.
we have learned many things, and we have learned many things from this this FDP. Experts from various fields came through online. It was a wonderful experience, and if you will provide us the this PPTs of all the experts, we will be grateful to you, sir.
Thank you, sir.
Is it possible?
Yeah, it is already uploaded in YouTube. We will share all the link and PPT through this FDP WhatsApp group given in FDP WhatsApp group. All the program has been recorded in a YouTube session. We will share
Okay,
it.
sir. Okay.
This
ठीक है.
session
Those who are giving the feedback, please introduce first.
Okay, sir. Myself, Dr. Jashandeep Singh. I am from BGIT Sangrur, Punjab.
Good.
Hello.
Good suggestion. Very good suggestion.
And it was a great involvement of Anukriti Sharma ji. Also, they have contributed a lot from for last 6 days.
Thank you, sir.
Okay. And a special thanks to Sani sir, Tiwari sir, and VK Giri sir, who gave such a platform for all the faculty members who took participated in various places in India. Thank you, sir. And I hope for that you will conduct such type of FDPs in future also. Hello.
Hello, sir. It is audible, sir.
Handy.
Anybody else?
Thanks, sir.
Okay, thank you, Jasprit ji.
என்ன பண்றீங்க தெரியுங்களா? இன்னைக்கு சப்பாத்தி ஹாஸ்டல்ல இவங்களுக்கு ஸ்பெஷலா தொக்கு செய்ய சொல்லிட்டு வராங்க. அதனால வெயிட் பண்ணி 2 பேரும்
Sir, good evening.
Yes.
Sir, good evening. My name is Amit Sharma, Assistant Professor from Pranveer Singh Institute of Technology and a research scholar in Madan Mohan Malviya. Sir, it's really very nice. First of all, I want to thank you for organizing such a good FDP, which is totally based on the recent trends. And it is actually what is going in the scenario of all over the world. The professors from different universities and the top engineering colleges, like Ashish Kumar Singh ji, Brish Singh ji from John Deere, Professor Ramesh Bansal ji from Dubai, Ranjan Kumar Behra ji, Vijay Pratap sir, and of course the lecture given by Manpreet Singh Manna sir. Definitely it gives the total insights what is going all over the world. The best part among the lecture was what was going in Dubai and what was going in US and John Deere sites in the farming sectors, how these things are being utilized. This is the most extensive part of this program. So I want to thank the patron, sir, Professor Jaiprakash Saini sir, our head of the department, VK Giri sir, A.N. Tiwari sir, and of course, our Dr. Navdeep Singh sir, whose sole responsibility was to maintain this program, and in order to make them a success, they played a very important role. And of course, the last, not the least, Anukriti, who has given the best of her in the program. Thank you, sir, for organizing such a beautiful event, and thank you so much.
Anyone else for giving a feedback? Okay. I finished the process of the feedback. Last, I complete my words. Once again, welcome to the feedback FDP, and we look forward to an enriching experience together. Thanks the organizer, speaker, and attendee for their participant. Thank you. Now the session will be led by Anukriti. Anukriti.
Okay. Yes, sir. Thank you, sir. Thank you for your valuable word. As we come to the final moment of this program, it is time for hear the guidance force behind the FDP. Our esteemed chairman of this FDP and head of electrical engineering department, Professor VK Giri sir. Sir, we request you to share your concluding remark and blessing with us. Over to you, sir.
Thank you, Anukriti. I think I am audible.
Yes, sir. You are audible. Yes, sir. You are audible.
Thank you very much. Finally, we come to the now valedictory function of this FDP. Of course, 2-3 feedbacks we got from the participants also. And what is my opinion on this is that hardly anybody can think of framing or organizing better than this feedback FDP, because you just see the overall conclusion wise there were 13 sessions. 4 sessions has been engaged by the abroad speakers, all the eminent speakers from the abroad, 2 from the USA, that John Terry and that San Francisco, Dr. Dubey, and Sharjah and Denmark. So that gives us the global scenario to the topic. And from after that 4 abroad session, we have 4 speakers from the IITs. Speakers, the name already has been taken so many times, and 3 from the NITs. two other speakers are also from there is the Vice Chancellor, and another is the REC Sonbhadra speaker. So you can just think why I'm just stating all these things, that this just shows you the stature of this one, the means what they call it as a how what was the cadre of the or what was the quality of the delivery by these type of eminent speakers. Of course, for the researchers' point of view, because I have seen almost all the time more than 120, 130, where at present it is 140, around 149. So attendance was also very good throughout that. And on the other hand, I can sometimes, what is my personal feeling is that these type of FDP, which is being organized in evening session and in online mode, is rather more beneficial than the organizing it, because in that way the attentiveness may not be this much. I don't know whether you agree with this or not, because we had so many meetings regarding this when AICT was planning for this type of hybrid mode and this online mode. Actually, it started from the after the COVID, because that time there was no any other option. But now this is what we call it as a blessing in disguise, and this mode has started, and now it is successfully being run. As I told you in the inaugural session, that we have organized already 4, and this is the 5th one, and we keep on doing this one as per the suggestions of the and feedback from the participants. Definitely, we will like to continue with this. That same topic. This topic is very recent, and a global flavor has been given, because all the things what is happening in the USA, all the way from the Sharjah, that and then Denmark, and then leading institutions, the researchers from the IITs, which is the leading institute, technical institute in the India, and the NITs. So that gives the global test, you can say, to the topic. So we will certainly continue with this one. The part 2 will certainly appear very soon under this scheme, Atal, or maybe some other scheme. And I would like to extend my thanks as well as congratulations to the both the coordinators, Professor A.N. Tiwari and Dr. Navdeep Singh, for
Thank you, sir.
For organizing such a interesting and well organized one week FDP. And I would like to request that, as per the request from the participants, you just go for and plan for the part 2 of this one. So with this, I would like to again congratulate both of you, and all the thanks. I want to thank all the participants for the patient hearing, and Ankuriti also for very nice conduction throughout this week, and your whole team, whoever is directly or indirectly involved in this organization of the FDP. So once again, thank you very much.
Thank you, sir.
All the best to all of you.
Thank you, sir.
Thank you, sir, for your inspiring word. Every successful event is the result of a collective effort, and it's time to acknowledge all those who have contributed to making this FDP a success. To extend heartfelt vote of thanks, I now invite our respected coordinator, Professor A.N. Tiwari, to provide the vote of thanks. Over to you, sir.
Thank you, Ankuriti. I am Professor A.N. Tiwari, and feeling really pleasure by delivering vote of thanks to all participants. First of all, my vote of thanks to our patron, Professor Jayaprakash Saini sir, who has initiated this program and asked us to do it, and really we enjoyed doing this program. Now I will thank our head of department. He always helped in all kinds of administrative support. And thanks to my colleague Navdeep Singh, and special thanks to Anukriti. She was always very sincere, and she was always throughout the 13 sessions. And my real thanks goes to all the resource persons. There were 13 resource persons, 4 from abroad, and remaining 9 from India. And all were they were all stalwarts from their fields, especially the field related to our topic, that is autonomous electric vehicle. So I thank to all participants also. Without participant, it cannot be organized. So it is really we are lucky to find such kinds of participants, very disciplined participants, very interactive, and really they are interested. So this course is really shows fruitful results. Being a coordinator, I thank to every participant. Now it is found that network cannot be done without network. So this program also makes another provision of networking with the resource persons and participants. So I request all participants to be in touch with the resource persons and work as per their requirements. They can interact with them, whatever technical requirement is there. And I have seen that all resource persons were always providing their email address and asking that whatever they need in future, they will be in touch. So I always thank to all so kind resource person who are available to our participants. Now I thank to everyone who is all around us throughout the program, and they are not in picture now. They are just working behind the curtain, and those people, without them, this program can also find hindrance. So I thank to them, and I again thank to all persons associated with this program. Thank you very much.
Thank you, sir. Thank you so much for your valuable word. As we conclude the formal proceeding, let us now rise for the national anthem, a symbol of our unity and pride.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
With that, we officially conclude the valedictory session, but before we part away, we have a quiz section after that. The link has been provided to you. Please attend the online quiz. Once again, a heartfelt thank you to all, to esteemed guests, speakers, participants, and the organization for making the FDP a grand section. Wishing you all for the best of your future. Having a grateful evening ahead. Thank you all.
Thank you, Anukriti, Nikita, and Amit Sharma, who are directly coordinated this program. Link has been shared in this chat box. It has
Thank you, sir.
it has a time duration near about 1 hour. It will it will be closed after 1 hour. Thank you. Have you got the link?
Yes, sir. Yes, sir. We got the link on the chat box.
Approximately, this link will be closed at 8:10 p.m.
Okay, sir.
Okay, Nikita, Amit.
Thank you, sir. Thank you for your kind words.
Thank you, sir.
Okay, thank you for coordinating this program. Thank you. Good night, all of you, and all
Good
the
night, sir.
participants.
Anukriti, if you can ask the all the participants if the form is opening.
No,
can
it's not
opening.
open this program.
It might be opening, sir.
No. It's not
Sure,
opening.
sir. Now it must be opening, sir. If you can check.
Yeah, yes, sir.
Sure, sir. Sure.
Yes, thank you.
Okay, thank you, sir. Thank you.
Yeah, it is opening.
Shall
Thank
we
you.
end the
Good night,
meeting?
all of you. Yeah, I'll
Yes.
leave this program. Thank
Okay.
you.
Thank you, everyone.
you